Hello guys, welcome back to today's video where we were in the middle of the preparation of colloidal solution, and today's topic, as we have covered in the previous lecture, the chemical method by which we can produce colloidal solution. In today's topic pep we'll be talking about peptization. uh, if I simply define it, peptization is the reverse of coagulation. While we all know that coagulation makes particles stick together, I mean that if these are two particles, the coagulation property makes them attracted to each other and they stick together. What peptization does is that it breaks them apart. It's more like a separation. So so by mere definition, we can know that while coagulation makes particles stick together to form a heavy precipitate, peptization breaks that precipitate back into tiny floating colloidal particles. And in order to break it down, we need a secret agent. We need an agent called electrolyte. I want you to remember this as you go through the lecture. I hope you have a clear idea. But for now, I'll be talking about the important terminologies as well. And what is the main mechanism behind this? The main mechanism is preferential selective absorption theory, which is also known as probably preferential absorption theory. The main mechanism of peptization is selective absorption theory. So if you imagine a big thing like that, where there is let's take that there is a precipitate of FeOH3 sitting at the bottom of, and we can take water as solvent as we have always taken. These are precipitate, probably. These are precipitate. Ferrous hydroxide is precipitate, which is shortly known as PPT. And I've told you before, in the mechanism we have an agent which we know as electrolyte. And in this process, we will be using FeCl3 as an electrolyte, which later breaks down into two ions, which is ferrous and chlorine ion, negative and positive. So the mechanism here, what happens is that when we put FeCl3 inside, which resides in the solution as Fe3 plus and Cl minus. I think I should have used a different color for that. I hope you understand it better now. What happens is the precipitate, or rather FeOH3 ferrous hydroxide, prefers to grab the ion that it already has in common. We have studied common ion effect. There's two common ions. So what the precipitate, which is this FeOH3, it prefers the common ion and it attracts it towards it. And what happens in the solution is that the precipitate, suppose it is a precipitate particle, it is surrounded by the common ion that we get, and it creates a layer like that. This ion gets attracted and creates a layer around the particle of the precipitate. So what happens is that we get a lot of particles having positive charge around it. We can see the positive charges here, and we all know that positive repulses each other, but they start repulsion to each other, and what happens is that this repulsion causes the exact reverse process of coagulation, which is it breaks down the precipitate. It repulses and it breaks down the precipitate. Common when it gets attracted, they create precipitate. But when they're not attracted to each other, they repulses each other. That's how they break those precipitate, and that process, that transformation, is known as peptization. So I hope I was able to give you a basic idea on that. Let's see, we have some example here, where we will be taking water as a solvent and freshly prepared precipitate. The thing is that it has to be freshly prepared, because if it sits too long, it becomes too dense and dehydrated for the ions to penetrate and break it apart. So it has to be freshly prepared precipitate. And we are also gonna put a common ion, we are also gonna put an electrolyte as well. And we have seen in our lectures before that to maintain a colloidal solution, we sometimes use KOH as electrolyte, because it is very important. We have seen how it keeps the colloids intact and prevents it from creating any precipitate, because precipitate destroys the colloidal solution. So in this video, in the first example, first colloidal solution, we're taking water and silver chloride and silver nitrate as well. Well, to mention you specifically, in the place of silver chloride, we can also take potassium chloride. We can also use other electrolytes as well. And to properly mention you, we have the electrolyte as silver nitrate. We can use different kinds of electrolyte for that. We can also use potassium iodide for it, and in these terms, potassium iodide would be observed, making it a negative colloid. We have seen the example of a positive colloid here, how it repulses each other, but in this term, it will create a negative colloid, as iodine is a negative atom. So I hope you understood what I talked about. And after that, what happens is that we have studied before that the common ion, which here is silver plus, it will create positive layer around the particle of the precipitate. Thus, it will create repulsion among the particles inside the precipitate when we shake it. So that's how you break the precipitate, and then you get colloidal solution. And that process of breaking the precipitate, as I have said you before, is known as peptization. In coagulation, the particles attracts each other and creates precipitate. In peptization, the particles repulses each other due to having created a layer of positive or negative. Remember, when they're creating layer of ions, like we have shown here positive, we have also shown here positive. Remember, every particles gets layered by positive ions. Thus, they repulses each other in the precipitate, resulting in breaking down the precipitate. And this process is known as peptization. Well, you can use my slides and take down the notes. I'd recommend taking notes, I think I one experience that I'll share, that every lecture, everything I learn, I try to write it down. No matter, doesn't matter if it's my pad or it's anything physical. I just try to write it down because it writing down things creates retention. My brain retention increases. So this is everything about the peptization. I hope you understood. And if you haven't, you can let me know in the comment. I will try to explain it again. So that's it for today. See you in the next lecture. Till then, have a good life.